In this video, we are going to see how we can determine the inverse of a function. And the function is a special relation that is 1x corresponding to 1 y value. So it's a certain relation. So 1x, you have only 1 y. If you have 1x but you have 2 different y, this is not a function, this is a relation. And how to find the inverse of a function is just switch x and y. So x to y, then go backward, output becomes input, input becomes output. That is a inverse. And you may have seen it before. So distance equals speed times time. If we want to solve for time, we move the way to other side by doing opposite operation. Then this t equals d over v. This is the inverse of this d equals v times t. So t is input, d is output, and in this equation, d is input and t is output. They are inverse. So we have seen inverse function before, and in this lesson we are going to investigate more in different forms. So if a table value is given, then we just switch x and y, then you will have the inverse of a function. If a graph is given, then we just reflect the graph in the line y equals x. That is means you just switch the xy coordinate to a new point, then you will have the inverse of this function. If an equation given, we just switch x and y and solve for y. So there are 3 forms given, then we find the inverse of the function differently. So we are going to see the examples, see them from the examples. So the first one is table values given. This is in original function x and this is y. And we know that for the table values, if we want to find the inverse, we just switch the xy coordinate. So the first one, 1, 5 becomes 5, 1. And 2, 7, switch x and y is 7, 2. So input becomes output, output becomes input. They are inverse. So 3, 9 becomes input 9, output 3. Input 11, output 4. Input is 13, output is 5. So this is inverse of the first function. This is function because 1x corresponding to 1y. So this is inverse. Inverse is just input, output, switch. So evaluate function f at 5. So 5 is input, x equals 5, then y equals what? So f at 5 give you 2 informations. Input is 5, f at 5. 5 output is 13, so f at 5 equals 13. So this function notation give you 2 information. Is a point. Input is 5, output is 13. So this is x, this is y. And this one we read it as inverse of function f at 5. Then we are going to look at the input is 5 now for the inverse function. So this is inverse function, input is 5, output is 1. So inverse of function f at 5 equals 1. And for the inverse function, this point is 5, 1. And evaluate inverse of function f at 5. So go from inside out to outside. So we start from f at 5. f at 5 give us 13. Then we look for the inverse function. Input is 13, then output is 5. You will see if we try other inverse input of other input, you will find out f at 4 is 11, then for this one 11 is 4, it cancel each other. So this input becomes output. If you have inverse, then function f again, they will cancel each other. So for the domain and the range, for the first one we have only 5 points. So for the function f at x, the domain is a valid x input. So we have only 5 points. So we just list all those values of x input. And for the range, we only have 5 points. So we list all the y values for the function f at x. Then for the inverse function f inverse f at x, you will see that the domain is just flip the range and the domain for the original function. So the domain is a range for f at x, and the range is a domain for the f at x. So inverse function f at x, the domain and the range is just switch. Then you have the new domain and the range. Okay. So just rewrite it, use a curved bracket. Okay, so this is for example 1. So if the table values is given, we just switch x and y, then you will have the inverse. And the domain of the f at x is a range for the inverse. So input becomes output, and output becomes input for the inverse of the function. So this is table values. Then we are going to see how we can graph, find the inverse function from a graph. So the graph of function, we are going to just switch the xy coordinate. Then you will have the new graph. So we are going to graph the quadratic function x minus 2 bracket squared plus 1. This is vertex form, so compare it with the vertex form, general form. You will have a equals 1, p equals 2, and q equals 1. So the pq is your vertex for quadratic, and this is a 1, 2, 1. So the vertex shift from 0, 0 to this right to up 1. And after that, we could use a step pattern, a value times 135. Then it is 1 times 135. And the step pattern means slope from vertex. So it is right 1, run is 1. So from this point, right 1, up 1. And the next point, the slope is 3 over 1, so it's up 3, right 1. Then for the it's symmetric, so left one up 1, left one up 3. Then this is a function f at x. So this is f at x, and because the graph of a function and its inverse is a reflection along the line y equals x, so each time when we are doing the graphing of inverse function, we want to graph this y equals x line. If you make the graphing of the inverse function easier, so this is y equals x. Then for the new points for the inverse function, we are going to just flip all the xy coordinate of the original function. So this is 4, 5. Then we are going to flip them. So this point 5, 0 becomes 0, 5. And this point is 1, 2 becomes 2, 1. And this point 2, 1 becomes 1, 2. This point 3, 2 becomes 2, 3. So they are symmetric of the and next point will be symmetric of this point on the line y equals x. So this is a 4, 5, it will be 5, 4. Then we are going to connect them. So this one and this connect them. So you will see this is a symmetric of this part, and this is a symmetric of this part. And the points that is on this y equals x line, they are not going to change. So this is a inverse function of f at x. So what we have done is just x coordinate, y coordinate, switch. So this is 5, 0, 5 becomes 5, 0. So before is 0, 5, then after flip it is 5, 0. And other points just flip correspondingly. So here we have done the table values, just flip x, y coordinate. Then this is your inverse function, and on the graph we switch x coordinate, y coordinate with y coordinate, then we have the inverse function. And next page we are going to see more examples. So this one is pairs, ordered pairs. This is another representative of the function. So for this one, this is x coordinate, this is y coordinate, and for the inverse function we just flip. So the inverse of function equals, we just flip them, 3, 0, 3, 1, 3, 2, 3, 3, 4, 3, 5, 3. So this is the inverse of this function. And now we want to see which points they don't change. So from here we are going to see 3, 3 don't change. X, Y, they are same. They are not going to change. So this one is 3, 4, 3, 5. So this one, we need to switch the x and y. So this one is 3, 4, and 3, 5. And from this one, these points, we are going to see if x equals y, then we switch them, it won't change. So we call invariant points. So when x, y equals, then these points don't change. It's an inverse of function. Inverse of function's definition is one x value corresponding to only one y value. And from here you will see when x equals 3, you have more than one y values. You have 0, 1, 2, 3, 4, 5. As long as more than one, this is not a function. The reason is 1x you corresponding to, because 1x input three, they are 6 y outputs and not same. So that reason is not a function. Function must be certain. You have one x, then you have only one y. State the domain and the range of f. So domain is all the valid x input. So this we have 6 points. We are just list all the valid x values. So we have 6 domain, and for the range you only have 1 y values. You only have 3. So this is valid y output. So state the domain and the range of the inverse, and we know that is just switch x and y, you will have the inverse. So it will be domain is 3. And the range will be the domain for the original function. So it's 0, 1, 2, 3, 4, 5. So this one is ordered pairs, how to find the inverse and the domain and range. So next example is going to be algebraically find the inverse. So for this linear equation, f at x equals 3x plus 2, in order to switch x and y, we want to replace f at x with y. So let y equals f at x. Then we have y equals 3x plus 2. For the inverse, we know that is xy switch. So we are going to switch x and y. So y becomes x becomes y. Then we solve for y. So this is the inverse output. So we move the 2 to other side by doing opposite operation. Then we move the 3 to other side by doing opposite operation. 3 times y, then it will be divide. So we have y equals x minus 2 over 3. And because the given function is in function notation, so we are going to replace y with the inverse function of f at x, then write it in function notation form. And it asks you if the inverse is a function or not. From the inverse, you will see we give x one value, you will have only one y value. So that is a function, or we could graph it. So y equals 3x plus 2, this is a linear equation, and we are going to start with b and after that use a slope. Slope is rise over run. So b value is 2 is y-intercept on the y-axis. So this is 0. This is b equals 2. Then the slope is rise 3, right 1. So 3 over 1 is rise over run. So rise is up or down, and the run is left or right. Positive means up 3, and positive 1 for run is right 1. You have 2 points, and you can connect these 2 points. You will have a straight line. So we need to move it a little bit. So this is a y equals 3x plus 2. Put arrows at each end. It means the graph keeps going. So this is your parent function, or you could use a function notation form. It will be easier for you to see which one is original function, which one is inverse function. When we graph the function and the inverse function, we want to draw the line y equals x, because function f at x and function f inverse of function f at x, they are symmetric on the line y equals x. So in order to graph the inverse function of this function, we could just exchange the x and y for the point. So this one 0, 2 becomes 2, 0, and this is a 5, 1 become 1, 5 becomes 5, 1. And for the other point, negative 1 with 7 is negative 1. Same point, so they will repeat this point. Then also we could use a step pattern 1 over 3, so it's up 1, right 3, and the same thing, down 1, left 3. We have this point, then we are going to use straight line to connect them. So it will be this way, and also go other side. So this is a inverse function. And you will see that if we draw a vertical line, these 2 points, they are symmetric. And these 2 points will be symmetric on this y equals x. And the x equals y point will be the invariant point. They will be on the y equals x. That point will be common point for function and inverse function. So the next question is an inverse a function? Then we could use a vertical line test. We draw a line, and each time you will see it has only one point of intersection with function f at x, then function f inverse of function f at x is a function. Yes. Because it passes. Passes the vertical line test. each time there's only one point of intersection. So one point of intersection each time you just move this line left right, you have only one point of intersection. Then this is a function. So we have graphed the function and the inverse function already. So now we have done the algebraically find the inverse of a function. What we did is we switch x and y, and for word problem, the variables are specified. For example, the distance equals speed times time. When we solve for time, we don't switch the variables, we just solve it. The reason is the time is in minutes, in hours, in seconds, and the distance, they have the different unit, so we are not able to switch them. So the unit not same, so we are not going to switch the variable, we just isolate the output becomes input. So we are going to see the next example. So restricting the domain to make the inverse of function. So it asks us to find the inverse of h at x equals x squared plus 5 algebraically. So we are going to switch h at x with y equals x squared plus 5. After we have the xy notation, we switch x and y. So y becomes x and x becomes y. Then we are going to solve for y. We move the 5 to other side. It will be opposite operation is subtraction. Then solve for y. We know it will be square root. When we square root something, make sure you have negative and positive at front. Then we put the y back to the function notation. So it's inverse of function h at x equals, one is plus positive sign, another one is the negative sign. So these are the two parts of the inverse function. So both of them are inverse function of the h and x. So we could put and there. So both of them are the inverse of function f at x. So it asks us to graph the function and its inverse. So x squared plus 5 is a quadratic function, and the vertex is 0, 5. Step pattern is right one up 1, right one up 3. So y equals x squared plus 5. The vertex is PQ. There's no P, so it's 0. Then step pattern is a value times 135. No numbers at front of x is 1. So right one up 1, right one up 3. This one means the slope. Then do the same thing, symmetric is left one up 1, left one up 3. For the right side is up 1, right 1, up 3, right 1. So connect them. This is your parent function. So h at x equals x squared plus 5. Then we would like to graph the y equals x sign, because with that graph, it's easier for us to graph its inverse. Okay, so this is y equals x. Then we are going to graph the inverse function. Inverse function is just switch the x and y. So this one is 0, 5 becomes 5, 0. Then this point is 1, 6 is 6, 1. Then it's kind of up 1, right 3. It is a flip the xy, flip the slope. And this one is down 1, right 1, down 2, right 3. Then this is a inverse of the function h at x. One is positive, one is negative. So it's the inverse of function. If we draw a vertical line, you will find out there are 2 points of intersections. Then this is no, it's not a function. Function must be 1x corresponding to 1y. If we draw a line here, you will find out x equals 9, and you have 2y. Y equals positive 2 and also negative 2. So 1x, you have 2 y's. This is not a function. You could say it doesn't pass the vertical line test. So there's 2 points of intersections at x equals 9. So each time you need to have only 1 point of intersection, then that is a function. So restrict the domain of the parent function, then to make the inverse a function. So we are going to see if we just restrict this h at x for 1 branches, then we flip it, it will becomes 1 branch from this inverse of function. So for the domain, if we just cut half of it, it will be h at x. Half of the domain will be x belongs all real numbers such that negative infinity less than x, then stop at the vertex less than or equal to 0. If we only have this half, then flip it, you only have the bottom half, it will be a function, no top half. So this is how you restrict the domain to make the inverse of function. So this is for quadratic function as a parent as a original function. Then the next one is graphing a function. The parent original function is a square root. After graph this one, then graph the inverse. So we are going to see there are more than one way to graph this 2 square root x plus 3 minus 5. We could use table values. So for this one, we could write the parent function is p at x, parent function equals square root x. Then we could rewrite f at x in terms of the parent function. F at x equals whatever input is under square root. So it will be pre bracket x plus 3 then bracket. So the number at front 2 is 2 times, then minus 5. So AKPQ, so we may change this P to the B at X to not to be same as the P. So we have A equals 2, K equals 1, P equals opposite -3, and Q equals -5. Then we could create a table values. For parent function is x and the square root x. This is the original parent function. So square root, we are not able to have x less than 0, so we pick 0, 1 perfect square number to get a nice number. Then we have 0, square root 1 is 1, square root 4 is 2, square root 9 is 3. Then the new y value is 2 a5 plus q. So a5 plus q is, this is y parent function, this is 0, so a times y0 plus q is 2 times y0 minus 5. So it's just b bracket x0. This is your y0. So this is what we are going to do. So 2 times y0 minus 5. Then this is a 0 sub in 2 times 0 minus 5 give you -5. 2 times 1 minus 5, -3. 2 times 1, 2 times 2 minus 5 is -1. 2 times 3 minus 5 is +1. Then for the x, this one is just x plus 3 equals x0. So for x equals x0 minus 3. So this is x minus 3, and this is from x divided by k plus p. So x minus 3, all this x value take away 3. So minus 3, 1 minus 3 minus 2, 4 minus 3 is 1, 9 minus 3 is 6. So the point is -3, -5 for the first point. Second point, -2, -3, 1, -1, 6, and 1. So they are the new xy coordinate after transformation. So -3, -5, -2, -3, 1, -1, 6, +1. So connect them. This PQ is your starting point. So 0, 0 point becomes PQ, the transformation. It is -3, -5. Then after that, it asks you to graph the inverse. So we are going to use straight line, graph a y equals x straight line. So y equals x. Then we draw the symmetric point for the f at x, then it will be the inverse of f at x. So this point is just flip it, this one, flip it, this one, flip. So this one is a 6, 1, then 1, 6, 1, 5, 1, 6. Then we connect those points. This one is -5, -3. So this is starting point. So this is the inverse of the function. So this is a graph for function and the inverse of the function, and question B asks you to find the inverse function algebraically. So we are going to just question B. This is question A, and we are going to replace the f at x with y, then switch x and y because inverse means xy switch. So we have x equals 2 square root y plus 3 minus 5. Then we are going to solve for y, move the number to other side, do the adding subtracting first. X plus 5, then after that move the 2 to other side, do the inverse, is opposite operation is division. Then after that we are going to do the square root. Square both sides. To get rid of the square root, it will be squared. Then equals y plus 3, move the 3 to other side, you will have y, and write it as a function notation. Y replace it with inverse of function f at x equals x plus 5 divided by 2 bracket squared minus 3. Then this is algebraically find the inverse of the function. Then this one said restricts the domain of the inverse function to make the function match your graph. We are going to see that you don't have to restrict anything because the inverse is a function. So question C is x belongs all real numbers. So you will see from square root to find the inverse, it's still a function, but for quadratic, if we do the inverse, it has a point of intersection 2, then it's not a function. Then the next one, find the inverse of this one and ask you if the inverse is a function or not. So we are going to replace g at x with y. Then xy switch, that is y, we call, after we solve for y, we call it inverse of a function. Inverse means input, output, switch. So x equals 5 over y minus 3 plus 6. Then we want to solve for y, we move the 6 to other side. Then plus 6. So x minus 6 equals 5 over y minus 3. Then we want to solve for y, we could do cross multiply or just flip. So we could flip both sides. We have x minus 6, y minus 3 over 5. Then in order to solve for y, we move the 5 to other side, it's multiplication. So 1 over x minus 6 times 5 or 1, then equals y minus 3. We move the minus 3 to other side. We have 5 over x minus 6 plus 3 equals y. Then how to determine this is a function or not? We could see the degree for y is 1. So if it's not squared, not even degrees, this one will give you a function. So this is a function. The reason is you sub in 1x value, then you will have only one y value. So you sub in 1x, do the calculation, you will have only one y value. Then this is a function. So continue practice. So this one should be example 6. So this one find the inverse again, and you will see this is a quadratic. So first step, we change f at x to y. So we have y equals 2x squared plus 56x plus 29. Then switch x and y. So output becomes input, input becomes output. Then after that, we want to solve for y. You have y squared y, you have two y terms. We could convert this one to vertex form. In vertex form, you will see there is only one x terms. So all we could do another way is we convert this one to vertex form first, because with x it's easier for us to manipulate this equation. So we are going to just, after we convert to vertex form, then we are going to switch x and y. So we still replace f at x with y, then vertex form. We are going to group the first two, then take the a value out, because vertex form is a bracket x minus p bracket squared plus q. In the bracket, you have one x there, so 2 bracket. We want x squared only. So each term divided by 2. We have x squared, then plus 28x, then plus 29. So equals 2. We could use a box method to change this one to perfect squared. So we draw a box. And this box, we want this length and the width are same. So x squared we put here, and we split the 28x into half. So this divided by 2, we have 14x. 14x. We use this box to represent the area for this rectangle or square. So we factor the first row, x squared, 14x, common is x. So this is one side of these two boxes, the width of this one. Then this is area of this box. Another side is do the division, so it's x. This area is 14x, one side is x, another side 14x divided by x give you 14. And do the same thing. So this one, 14x is area, one side is x, another side will be 14. Then from here you will see we have x plus 14 times x plus 14 as a two sides. So we have x plus 14 squared is closer to the a bracket, x minus p bracket squared already, just need to figure out the q. So in order to have x plus 14 squared, we need to have a number here. So 14 times 14 give you 196. And inside the bracket we don't have any constant, so we need to make sure we minus 196 to get 0 here. Then add together you have x squared plus 28x. It works. So minus 196 didn't contribute to this perfect squared, so we are going to take this one out. Be careful, you have a 2 at front, so 2 need to times with this negative 196, then plus 29. These two like terms will give you the q value. So we have 2 bracket x plus 14 bracket squared, then multiplication first, then plus 29, you will have minus 363. So this one is y equals, from here you will see this variable appear only once. So if we want to solve it, it will be easier. So we want to switch x and y now. Then you are going to have x equals 2 bracket y plus 14 bracket squared minus 363. Then we want to solve for y. This is your inverse function's output. So we do the opposite operation. We move the minus 363 to other side first. So we do the, when we solve for y, we do the backward of BEDMAS. So we do the adding, subtracting first. So x plus 363. Then we move the 2 to other side, will be division. Then we do the, you will have y plus 14 bracket squared. Then we need to get rid of the squared by doing the opposite operation to squared is square root. And we know whenever we square root, we need to have positive and negative at front. The reason for that is negative times negative give you positive. So both the positive number and the negative number will give you the same squared. And y plus 14, we move the 14 to other side. So this is a isolated y. Then we want to change this one to the function notation inverse. So y is inverse of function f of x equals plus minus sine square root x plus 363 over 2 and minus 14. So this is done. And from the example before, we know that will give you the 2 branches. So the inverse of function f of x is not a function this time. And how you are going to be able to have it as a function, you could restrict the f of x domain. So on the left side of this vertex, then you will have only half of the branch, half of this graph, then you will have reflected, you will have the function. Okay, so this is negative 14 negative 363. This is your original vertex. And this point, you flip it, you will have the inverse of the functions, this point. So that is for example 7. When you are having a function that you have 2x input, then you need to make some changes to have 1 x input. Then you switch it. It's easier for you to isolate that one by moving the numbers to other side. And example 8 is we try to test this one. Function f bracket inverse of function f at x. It will give you the input, and or you could try inverse of function f at x. It will give you the input. So in other words, they cancel each other. So we are going to see if it works. So from this one, f at x equals 4x plus 5. In this equation, we have the f inverse of f at x. So we want to solve the inverse of f at x from f at x. So we replace f at x with y. Then we switch x and y. XY switch. This is a definition of inverse function. X equals 4y plus 5. So this is your inverse function. We just need to isolate y. So x take away 5, then divide by 4. This will give you the output of the inverse of function f at x. So we write it as, change the y as a inverse of function f at x. It's x minus 5 over 4. Then we are going to see if f at inverse of function f at x equals what? So we are going to sub in inverse function f of x is x minus 5 over 4. Then we sub this one into the original equation. Function is, this is input, change the x with x minus 5 over 4. Then plus 5. This is a times fraction, so we use numerator times numerator, denominator times denominator. So 4 times x minus 5 divided by 4, 4 cancel out, you have x minus 5 left. Then plus 5, you will see it is x. That is your first thing is correct. Then we are going to check the second one is correct or not. So second one, the inverse of function f at x, we sub in the f at x as the input for the inverse. So f at x is 4x plus 5. Then we sub in this 4x plus 5 to this x. So 4x plus 5 as x as your input for the inverse function. Then minus 5 over 4. You will have 4x over 4. It is x. So this is proved. And why it makes sense? So we could write it as this one. This is a function machine. So this is function machine. Then what you are going to sub in is, you put x here, it will give you f at x. And for the inverse function, inverse function is, you put this f at x here, it should go back to output becomes input, then this input becomes output. So this is what represent here. So this one, you put f at x to the inverse function, it will give you x.
Thanks for watching.